we're doing our calculations for the lab. So whenever you're doing a science problem, you write down what you know. Then you have a plan on how you're going to solve it. And then you solve it. Okay? So let's write down what we know. What do we know? We know that the sodium hydroxide concentration is equal to, and I'm going to put a square bracket that means concentration. So just as a note, square brackets means concentration. It's on the board too. So if you want to look, you can see it up there. So when talking about concentration, you know that the concentration of sodium hydroxide is 0.1 molar or 0.1 moles for every 1 liter. Okay? I also know of this idea that I learned in math called canceling. So I can cancel. All right. So canceling really helps a lot in science. All right. What else do we know? Well, let me continue writing what we know. We know also, I'll pause. The other thing we know is that when the concentration of acid equals the concentration of base, there will be a change in color. So we knew that as well. Do we agree that that's pretty much what we know? Yes. And we're trying to figure out, so the next question is, hey, take it easy. So the question we have is, what is the concentration of acid? That's the question we're trying to answer in moles per liter. All right. We know one other thing, by the way. We know how many drops per milliliter. What's the number of drops per milliliter that you guys figured out for your dropper?
For the first time.
The first time, yeah, with the water, you had to count how many drops.
That we did. We did 85 drops.
So there's 85 with the water, right? Your average was 85 drops. So 85 drops it takes for every 1 milliliter to have 1 milliliter, right? So it takes 85 drops to equal 1 milliliter. And then the other thing that you definitely know is how many drops did it take to get the acid and base to equal to each other?
84.
So it took 84 drops for neutrality. Right? And that's this. That's when these two things are the same, right? When the two drops, or when the two concentrations are equal, they're neutral. So let's do the math. So we're going to start off with 84 drops. The first question is, this doesn't help us. 84 drops doesn't help us. We need to find a volume. How do we find volume? Well, we're going to use that canceling business. So we have 84 drops is what we have. And we want to get rid of drops, and we want to have volume. So what we do is we set up, since remember, when you have this going on, when this here is, you can consider it a conversion factor, because this over this means that's equal to 1. Does that make sense? So I can flip it. I don't have to keep it like 85 drops over 1 milliliter. I can put 1 milliliter equals 85 drops. So I can put it the other way too. They're the same number. Does that make sense? It's kind of a rule of math. And what I can do, because I set it up this way, is I can do that. I can cancel. Does that make sense? And that leaves me with milliliters, doesn't it? It's the only thing that's left. Except what's 84 divided by 85?
0.988235529.
0.098?
No, 0.98.
0.98.
Yeah.
0.98. Let's just leave it at 0.98, just for now. There are rules about this, but we're going to just go ahead and do it this way. So it's 0.098 milliliters. So now we have our volume. That really helps us a lot, except that it's in milliliters. And I know that we were doing calculations we have the concentration of hydroxide in liters. So we got to convert milliliters to liters now. All right, so I got 0.98 milliliters, and then I want to convert it to liters. Well, I know something. Hopefully you know it too. If you don't, that's okay, but you need to know it eventually. I know that 1,000 milliliters equals 1 liter, right? I know that because I know my metric system. I know my scientific system of measurement. International system of measurement. So milliliters cancels milliliters. And so what am I left with? Liters. So what's 0.98 divided by 1,000? It's 0.000.
No, that's a 98.
98. All right. Sometimes I add an extra zero because I don't know why. So 0.0098 liters, okay? So that's great. Now I know the volume that was required to neutralize the acid. So theoretically, the volume, this is 0.1 moles for every 1 liter. The concentrations should be equal, right? The base, this is for the base. At this point, the base should be equal to the acid concentration because they neutralized each other. So if the base concentration is 0.1 moles per liter, the acid had to be a certain number of moles for 0.00098 liters. And so if we take and put X number of moles, if we go ahead and use let me use a different color. Oh, I thought it'd have it. I don't want to use blue. I'll use yellow. All right. If we have an X number of moles over liter, and we have to solve for X, what do? You think you've learned this in algebra probably in middle school, certainly hopefully in high school by now. Huh?
Times it?
Yeah, that's right. Good. You multiply this side by 0.00098 liters. Well, of course, in that case, when you do that, these two cancel, right? And what you're left with on this side of the equal sign is X moles. But whatever you do to one side, you have to do to the other. So this is times 0.00098 liters. So now 0.0098 liters. What happens to liters here on this side? Of course, this is over 1. When you multiply these two, what happens? What happens to liters?
Does it cancel out?
They cancel out, right? The liters cancel out. So 0.0098 times 0.1 is 0.00098 moles equals X moles, right? So that's our X. This is the number of moles for this many liters.
You know you put 4 zeros?
Yeah.
Okay.
Because, see, what happened was when you multiply, if you take 0.0098 and multiply it times 0.1, you get another extra zero in there. They're just moving the decimal once to the left. You can do the math just to make sure I'm not wrong, but I'm pretty sure that's right. So that's great. Now we have to let's check our answer. Something we like to do in science is make sure we're right. We're going to check our answer. And so we said that the sodium hydroxide, the base, was 0.1 moles per liter, right? Didn't we say that? Mm-hmm. In fact, we can just use molar, moles per liter. So what was the acid concentration? Well, the acid concentration is 0.000098 moles divided by 0.00098 liters. So what is divide, do the math. I can tell you pretty sure should be equal if it's right. What is the answer? Do you have it? Should be equal to 0.1 molar. I'm pretty sure it's equal to 0.1 molar.
Yeah, it's equal.
All right, so it's 0.1 molar. So you did it right.
Yeah.
The number of moles are equal. And that makes sense. Are we good?
Yeah.
No.
They weren't equal.
Huh?
They weren't equal.
That's a good, see, that's the kind of question. That's where people are like, what kind of question could I ask? I already understood it. I got the right answer. What kind of question can I ask? Well, the kind of question you can ask is, well, what if they weren't equal? Well, you probably did something wrong. Or your theory's wrong. Maybe the explanation of the problem is wrong. That's possible. But this is a pretty tested theory, so it's unlikely it's wrong. So you probably counted the wrong number of dots. Maybe you used the wrong maybe the concentration of base wasn't 0.1. Maybe that concentration was something different. You see what I'm saying?
If it was wrong, you would have to retrace all of your steps.
Yeah.
Do it all over again.
Yeah, you'd have to do it over and over and over again to verify to find out where the problem was. Like one team, when we did it the first time, they didn't mix it. And so they probably added 4 or 5 extra drops, 10 extra drops. They might still get 0.1 molar. There's a lot of room for error because see how big the numbers are or how small they are? If you make 1 drop too many or 2 drops too many, it probably won't make a difference for this particular titration. It's pretty hard to mess up this titration. But when you do some titrations, 1 drop can make all the difference. 1 drop off. All right, so that makes sense to everybody?
Yes.
Everybody had it? All right, excellent.
So you want us to either use these notes, shoot it down, or watch the video?
You can watch this, do that. No, you don't have to watch it. If you got it, you have your calculations, you can do this, or you can copy these notes and write them in. Just submit them, just so I know that you've done it, and you understood it. That's really the only reason I'm asking you to submit the stuff. I'm just checking to see you got it. So if you wrote these notes and submitted them, that's fine. Or you could do the notes from your work is fine. Whoever is on your team. All right, we're all good?
You said you were going to show me how to do a scan.
Yeah, let's do that now, and then we'll fix your problem.